All right, in this lesson we're going to talk about solving inequalities. So I have a few inequalities up here that we're going to go through and solve. We're also going to take the solutions and show them on a number line. Now, solving an inequality is basically the same thing as solving an equation. Okay, so if I have the inequality x plus 18 is greater than negative 11, if this were an equation, it would be x plus 18 equals negative 11. You would solve that equation by subtracting 18 from both sides, and you would get that x is equal to negative 29. And so the value of x is just negative 29 in an equation. If I were to show the solution on the number line, I would have my number line and put some numbers on it. And the solution would just be the one number, negative 29, that it says x is. That's how you solve an equation. Now, in inequality, we do basically the same thing as an equation. So in this one, first one now, we're going to subtract 18. We always subtract from both sides. So when you subtract 18 from both sides, you get x, and on the other side you get negative 29, just like the equation. The difference, though, is now the left side of my inequality is greater than the right side. When I take 18 away from both sides, the left side is still greater than negative 29. And so when I go to show my solution on the number line, what I generally do is put the number negative 29 right in the middle, and then put a couple of numbers to the right that are bigger, negative 28, negative 27, and then a couple of numbers smaller. And I just show this part of the number line. In this one, I don't put a dot on negative 29 because negative 29 is not greater than negative 29. I put an open dot. And then the numbers that are greater than negative 29 are all the numbers to the right. So I have this when I put it on the number line. So I'm showing my solution. And I've shaded all of the numbers that are greater than negative 29. A simple way to check it is to take any of the numbers that are shaded, negative 28 or negative 27, put it in where x is, and make sure you get a true statement. Negative 28 is greater than negative 29, so that's correct. So the only difference with solving inequalities is you have to be careful. Anytime you multiply or divide both sides by a negative number, your inequality symbol is going to change. So in the first one, since I was subtracting, doesn't matter if I subtract positive or negative, the inequality stayed greater than. Now down on this next one, you're going to divide by 8. So I'm going to divide by 8. The left side is going to become x. The right side is going to become negative 4. Since I'm dividing by a positive number, the inequality symbol stays the same. Had I divided by a negative 8, I would have changed the inequality. So I get that x is less than negative 4. Show it on the number line again. I'll put negative 4 there. Two numbers bigger. And how you show it on a number line is going to be determined probably by your teacher. I just show the portion of the number line that has the number that's in my solution. Some people would always insist on seeing 0. Again, it's an open dot because it doesn't have or equal to. And I shade to the left because those are the numbers that work. If you put negative 6 in, negative 6 is less than negative 4, and that's true, and that's why that's correct. Next page, I have two more. So if I'm going to solve this first equation, the first thing I'm going to do is subtract 12 from both sides. The reason I'm subtracting 12 is because my 12 is positive. It doesn't matter that there's a minus sign. I subtract 12 to get rid of a positive 12. When I do that, I'll get negative 6x on the left, and I will get negative 27 on the right. My inequality symbol stays the same because I was subtracting. It only changes if I multiply or divide by a negative. Now the next line, I'm going to divide by negative 6. So here I am dividing by a negative number. So I'll get x here. This would end up being 4 1/2. But since I divided by a negative number, I would go from greater than to less than. And there's my answer. I'll put that on the number line since I have 4.5. What I would do is I'll probably put like 4 here, 5, 6, 7. The numbers to the left. 4.5 is going to be in the middle. So put my open dot about where 4.5 is. The numbers that are less than 4.5 are here to the left. And now the last example that I have on this one, we're going to distribute -3. When you distribute, okay, you're not multiplying both sides. Okay? You're just doing the arithmetic. I'm simplifying the left side. So I would get -3x plus 24. Okay? The 10 stays the same, and the inequality symbol stays the same because I haven't done anything to both sides. I'm only rewriting the left side. So I'm not, the left side is greater than 10 now. When I rewrite it as -3x plus 24, that's the same thing. It's still greater than 10. At this point then, I'm going to subtract 24. And this I will do on both sides. So I'll get -3x. I'll get -14. The inequality symbol stays. And then the last thing I would do is divide by -3. And if I divide by -3, this would be x. And over here I would get 4 2/3. Since I divided, this would become less than. And there's my answer. All right, so solving inequalities is just like solving equations, except anytime you multiply or divide by a negative, you have to switch the inequality symbols. And now here are a couple of word problems where it says to write an inequality for the values of x. In these, we're dealing with areas, so a little geometry connection. The first one is a rectangle, and the formula for area of a rectangle is length times width. So what we do in this one is, since area is the same thing as length times width, I'm going to put length times width right there where it says area. So I'll do length times width is greater than 24. Now the length and the width are 8 and x, so I have 8 times x is greater than 24. I would divide both sides by x, and I would get that x is greater than 3. And then since I know it's meters, x is greater than 3 meters. And that would be my solution. So any value that's greater than 3 meters is going to result in an area that is greater than 24 square meters. On the second one, I have a triangle. So my formula for area of a triangle is area is equal to 1/2 times the base times the height. So now this is going to go in where area is. I have 1/2 base times height. That's area, and that has to be less than 30 square inches. So when I plug everything in, I get 1/2 times 6 times x, which is less than 30. And that ends up being 3x less than 30. And when I divide by 3, I get that x is less than 10 inches. So any number less than 10 inches for a height is going to make the area of that triangle be less than 30 square inches.